All righty, welcome everyone. This is going to be part 3 of the module 5, and this one we're going to go a little bit deeper. In the previous two videos, we talked about the just a basic overview of local storage and how that works. In video number 2, we then went and dived a little bit deeper into the MBR and GPT and how we can go and set those up. And then now in this one, we're going to talk about the idea of mounting these devices. Like once we've already created them, how are we going to mount them? And then we're going to go ahead and go into a little bit deep discussion on this idea of swap space. Now, I will say this, swap space is a very important piece that you need to go ahead and learn about for the Linux operating system because it's very, very crucial. You don't have swap space, it could be a bad time. Let's go ahead and actually dive a little bit deeper into this. Let's go ahead and get an idea. So what does this actually mean? When I say mounting, I'm going to go ahead and move this over here. When I say mounting, what do I actually mean when I say I'm going to mount or I need to mount this device? Well, actually, we can go ahead and what this means is that, making the basically the storage device accessible. So we can do this by a couple different ways. One of the commands, and this is going to be your new command, we can do a mount, and this will display the mount information, the mounted. Ooh, I don't like that. That's there. There you go. So that displays the mounted file systems. I'm going to do FS for file system, just like I did before in the previous videos, and its attributes. Let's look at this and see what this does. Let's go ahead. I'm in my command window right here. So here you can see, ooh, that's really horrible, but at least you can see. So these are all the different mounted file systems, okay? These are all the different mounted file systems. And over here, you can see the different information. So C group, this is mounted on this actual path. And this is the path. That's the type, the C group. These are going to be the permissions that I have for it, and this is its name. It's called systemd. Okay. So we have these ideas of how these can work and everything. If I actually had a USB drive plugged in, it would show up here. Here is going to be /dev/sda1. This is going to be my main hard drive. This is mounted on /boot because remember, this has got the boot record on there. It's an XFS type. Okay, and I have the rewrite permissions. I have the relay time permission, the sec label, the attribute 2, inode 64, log buffs 8, log buff size 32K, no quota. So a lot of those don't make any sense. You'd have to go ahead and actually read through the mounting man page to kind of get an idea of what these actually mean. But you can see no quota means that there's no quota set for this one. So once I fill it up, I fill it up, especially if there's multiple users on this box, which we're going to a little bit later in module 6. We talk about things such as setting up quota devices or quotas for hard drives. All right, next. So the way we can do this, and if we want to mount something, so let's say we want to mount a device, right? So the command we're going to do is like this. We're going to type in mount, and then we're drive to mount. So what is the drive we want to mount? And then here's the mount point. Okay, let me go ahead and move this out of the way. Can I move it out of the way? No. Okay, cool. So this is how we structure the command. We type in the command mount, and if I wanted to, I can do mount help. Remember, the help commands are very helpful in this kind of situations. So we have, this is used to mount a file system. Notice it says mount, the mount point, the drive, and then drive to mount, and then here's the target. That's where we wanted to go to, okay? So mount all file systems mentioned in the S tab, but we talked about the S tab, and we talked about how what its purpose is, and then in this actual module, we're going to talk about it a little bit more and how to actually configure it. So we can use this to mount. Now, what happens is like, you know what? I'm done with the USB. And think about this way, when you go ahead and actually plug in a USB, it's actually auto mounting. And then when you go ahead and unplug it, it's unmounting. But remember, you're not supposed to do that with USBs. You're supposed to go in there, right click and do, eject. That's actually telling the operating system, hey, I'm going to unmount this device. So surprisingly enough, if we use the word mount to mount an actual hard drive or storage device, we can actually use the term unmount. And the unmount, does the same thing, which is even cooler because it makes logical sense. So we can go ahead and do unmount, tac help. Sorry, I mistakenly, it's not unmount, it's umount. Umount, unmount. That was my fault. So unmount the file system, okay? And this is how we go ahead and unmount devices, storage devices, okay? So we have this idea here. Now, what happens if we try to unmount something, but unmounting, when you try to unmount anything, it gives you a problem? Well, think about it this way. Remember, sometimes when you try to go ahead and get rid of something, or you try to go ahead and attach a file to an email, and it says you can't do that because that file's still in being used. So this is called in an operating system where we call this locking the file or the storage device. So you can't access something that's currently being written to. Okay, so if you try to unmount something and it gives you an error message, a lot of times because that actual device is still being written to, so you need to go ahead and finish out. So like if you have a USB and everything and you're working on a project for another class, if you try to remove the USB and everything else, or if you were to unmount it, it's going to say, hey, you can't go ahead and do that because the fact that there are things still being written to this actual device. And you probably don't want to go ahead and not actually go ahead and keep them up to date. So think of it that way. It's a safety feature to go ahead and make sure that you don't do something you're not supposed to do. So we talked about this fstab, and what the /etc/fstab, what this actually does is this actually handles auto mounting. So this actually handles auto mounting. And the way we read this is we can read this as the following: the UUID of the drive, the mount point, the file system type. I'm going to make this a little, actually, I'm going to go ahead and pull this out because I don't like the fact that, oops, I'm going to put this in a separate thing. There we go. Let's make this a little bit bigger. Okay. So how do we read the fstab? We need to do the file system type. And then we also have to give it a mount option. And this is going to be, then we give it a dump number. And then we give it a pass, okay? And so we can get a good detail on this and everything over here. I have it. That's our SMB backups. Oh, I don't have it. Okay, cool. Well, I can go into it. Let's go ahead and actually change directory to /etc. And I'm going to do a VI on fstab. So here's what it looks like, okay? Here we go. The UUID, the mount point, the file system type, the mount options, and then this right here is 00. Now, let's go ahead and let's actually just do a quick Google search. Understanding fstab. So you can see right here, this, you can actually just Google it and like, hey, what does this mean? So again, this is the unique identifier or the label you want to go ahead and give for that actual storage device. Field number 2, this is going to be the mount point. So where is this be mounted in the operating system? Is this going to be swap? Is this going to be under /dev/PTS, media floppy, And then you have also this idea of the file systems. It could be ext2, ext4, XFS, it's going to be NTFS, FAT32. And then you also have the mount options. These you can go into a little bit of detail, and you can actually dive a little bit deeper into the mounting options. Notice right here it says no auto mount. That means it's not going to automatically mount that one. And then this one right here, there's ACLs established this one. So there's going to be ACLs, or it's the access control list for that actual device. Under specific users, and then user has a writing attribute, okay? Field number 5 indicates whether the backup utility dump for the file system. 0 means no backup. So if you turn it on, that means you go ahead and actually get a backup. You turn it off, it would be 0. This indicates the sequence of the file system checks when the system is booted. So notice, okay, let's go back to my hard drive. 0, 0, okay. Let's look at that. The file systems that are not to be checked. So if ever there's a file system check, it's not going to check that actual file system. When would you want that to happen? Well, it just depends. If you have issues or anything, you need to go ahead and do that, or you need a root directory, or all the modifiable file systems. File systems on different drives are checked in parallel. So this is going to be very, very helpful in understanding that. So we can kind of see how that works in this kind of instance. But a lot of times I think you either see 0001, okay, 00 or 01. And you'll get practice with this in the activities. So we're talking about this FS tab, and you can actually go ahead, and this UUID doesn't have to be this. You can give it any type of label. Notice right here in the example, they just called it whatever they wanted to. This is going to be /dev/HDA, and notice that's the root directory right there. Notice it says 1, and 1 stands for the root directory, okay? So we can kind of see that this actually makes a little bit of sense. Now, the next thing is we're going to talk about, well, when you build a Linux operating system, okay, we have this idea of a computer. The computer has limited memory, okay? No matter how much memory you put in there, it's still limited. And in this case, Linux actually has a really cool feature. Okay, so I'm going to pivot to this next step, which is going to be talking about this idea of swap. So this idea of swap or swap space is really important for you as a Linux administrator, someone that's in Linux, if you're going to be doing some type of Linux cybersecurity, or if you're going to be just working with Linux in general. So what does this mean when I say swap space? So think of it this way. You have a set piece of memory. In the Windows environment, this is referred to a lot of times as paging files, okay, or virtual paging files. And this is what it really does. So if for some reason, for whatever reason, your operating system runs out of memory, then it activates a swap space. And this is when this is what this actually means. So this is used when the OS runs low on memory. So it basically you can create a separate storage device or a file that you can use as swap space to help bolster the memory. Now, why is this important? Well, couple of things. In the cybersecurity world, if you have a baseline of your system, and all of a sudden your system starts going haywire and you're running out of memory, you have what's called a memory leak, okay? The swap space may save you in the fact that it may actually keep your system up enough so that way you can investigate the situation, all right? Not a bad issue. Or maybe you need to make a copy of the drive while it's active. Well, you can do that as long as you have memory. Once you run out of memory, the computer doesn't know what to do and it locks up. And a lot of times back in the day, we would call this the blue screen of death. Sometimes it actually was really related to the memory issues, okay? So we had this idea that we can go ahead and if we ever run out of memory or run low on memory in the actual computer hardware, we can use swap space or a swap file to help go ahead and facilitate the continuous running until the computer stops being bogged down, okay? Now, this also is you won't be able to actually see it, but it's actually created during the installation. And you can also you can add extra partitions or files to this. So that's even better because you can have a whole device dedicated to swap, have a whole separate extra hard drive, or you can create you partition a file on the drive itself that can actually go ahead and act as a swap space. And that's very important. So again, let's go ahead and actually look at this a little bit further and just kind of so we talked about this. We say it can be a partition. Swap space can be a partition. Just review. I can't spell. Or file. Okay. Now, there are some pieces we need to understand. Partitions are actually quicker than files. Now, why is that? So, why is a partition quicker than files? Well, files are still actively on the drive that's actually bogged down. Okay. So if the drive is bogged down and it's using swap space, it's not going to be as quick as if you had a separate storage device that had swap on it. Okay. So we had this idea that basically, if you have a partition that actually is dedicated to nothing but swap, that's a separate part of the hard drive. Minus that's being subtracted from the overall. So let's say you have 100 gigs and you go ahead and partition 25 gigs for swap space. That means you have a 75 gig hard drive. Okay. If you were to go ahead and say, you know what, I'm not going to do that. I'm going to give my operating system the full 100 gigs. And then I'm going to go ahead and give it within 100 gigs. I'm going to partition I'm going to use that word loosely. Let me rephrase that. I'm going to build a file, a swap space file on that 100 gigs that takes up 25 gigs. Notice the difference, okay? We have a separate partition versus something that's on the actual hard drive itself that's not individualized. The partition is actually going to be individualized. Now, the other thing is too, we have to look into is that, we may not be able to add new devices, okay? So when we're talking about swap space or anything, we may not be able to add any type of new device. So how do we go ahead and circumvent that? We have, let's say what if we can't add a storage device? What if we've already taken up all the USBs and there's not enough actual USBs to do that? Or there's not enough bays on your actual hard drive to add another storage device? Well, then in that case, you have to create a swap space file. So that's really important. And then, the other thing I want to go ahead and really hit on is the fact that swap space is very, very unique in the fact that the swap files in particular, should only really be used as a secondary swap solution. Because if you have the option, you should actually go ahead and create a partition. Okay. So there is some commands that that are really, really important. We're not going to do that in this actual activity. But there are some commands that you need to go ahead and be familiar with. You can be familiar with in creating swap space, like make swap. That's how you go ahead and do that there. You can go ahead and actually talk about make swap. You can go ahead and do partition and tilelet swap. You can actually do that with the commands we talked about in the in module 5.2, or and if we want to go in a little bit deeper, go back to 5.1. So you can get this idea of how this actually ties in to all this. So that's all I have for this one. I just want to talk about swap space. You just need to know what it is and know that there are commands that can go with it. And if you wanted to, all you had to do is go ahead. Let me just log in real quick. Apropos swap. There we go. So here's all the swap commands. So we can do swap on, swap off, okay? We can do set up a Linux swap area, so make swap, so that's how you make the swap. So we can actually do swap label, print or change the label, or your idea of a swap area. We can go ahead and do swap on to turn on. So let's actually do that real quick. Let's just type in swap. on and see what it is. So notice that on my swap, I have a partition that's approximately 1.6 gigs, and I've used up 588 megabytes of it. And this is actually on dev DM TAC1. And notice the priority number 2. This doesn't make any sense with priorities. We'll talk about a lot later in this course. But just know you can do that. If I want to turn it off, I just type in swap off and then give it the name, dev TAC DM TAC1. If I wanted to make the swap and I don't have one, I can make the swap here. So I can just type in make swap, TAC help. This is set up a Linux swap area. I can do a couple different things. I can go ahead and do a swap space. I can do a partition. I can force it, check it. What if I have bad blocks before creating the swap on my hard drive? I need to go ahead and fix that. I can do that with the swap. So this is this idea. Again, you need to understand the purpose of it, some benefits to you, so using a partition versus a file. And just know that like the commands of like make swap, swap on, swap off. Those are the ones that you're going to be kind of need to know for this actual section. Other than that, that's all I have for you in 5.3. In the next actual section, where we talk about 5.4, and that one's going to be taking the idea of local storage, and we'll talk about some advanced features. And in this one in particular, we're going to be talking about things such as like encryption stuff. So be prepared for that one. Other than that, I'll see you on the next video.